All right, two proportion hypothesis testing is next. So in this case, they'll give you two samples and two proportions. I personally think that this is the hardest type of hypothesis testing because this is where we have to pool. So we still are using phantom since we're running a hypothesis test. Your null hypothesis should always be that the difference between the proportions is 0. Alternatively, we'll try to show that it's either greater than, less than, or not equal to 0. A big thing with this two proportion hypothesis test is that we need to pool. Our entire hypothesis is based on the assumption that the two proportions are equal. If they are equal and their difference is 0, then it shouldn't matter which group of people come from. So with this pooled, what I'm doing is taking all of my successes from both groups, putting them together, finding what proportion I would expect the successes to be out of the entire population, so both of those samples. Once I have this p-hat pooled, remember this is going to be a percentage. Once you have that p-hat pooled, we can then use it to find our standard deviation. Okay, so let's go ahead and look at an example. This says the Journal of the American Medical Association reported on an experiment intended to see if the drug Prozac could be used as a treatment for the eating disorder anorexia nervosa. The subjects, women being treated for anorexia, were randomly divided into two groups. Of the 49 who received Prozac, 35 were deemed healthy a year later, compared to 32 of the 44 who got the placebo. Okay, test an appropriate hypothesis and state your conclusion. That wording there that says test an appropriate hypothesis is telling me that I should be running a hypothesis test. Hopefully you're noticing there are two groups. There are the 49 who received Prozac and then the 44 who got the placebo. So definitely two different groups, two different proportions here. We are still going to be using phantoms. So since I have two groups, I am going to have two p-values listed for my parameter. The first one is just going to be from the first group. So it's not telling me the percent that I expect, but I'm going to have P1 represent the percent of healthy women with Prozac. So these are the percentage of women that are healthy after taking Prozac. My second group will be the percent of healthy women with the placebo. Okay, my hypotheses, I'm going to start with assuming that the two p-values are the same. If they are the same, their difference should be 0. You could start with writing it as P1 equals P2, but we do like to show that that subtraction is equal to 0. Okay, alternatively, we'll try to show some sort of difference here. Now, it's not really telling me exactly what kind of I'm trying to test. My assumption is that I'm trying to show that Prozac is, more efficient in treating this disease than some kind of placebo. So I would want the percent of healthy women who receive the drug to be greater than with the placebo. So when I subtract P1 minus P2, this should now be 0, greater than 0. Okay, A is my assumptions and conditions. So first one is that they must be random. It does say that they're randomly divided, so we're good there. Next, I need both groups to be less than 10% of the population. 49 received Prozac, 44 received placebo. those are definitely less than 10% of people that are receiving both. So 49 and 44 should be less than 10% of all people who receive drug and placebo. You could also say that the 49 and 44 is less than 10% of all people that have anorexia. Okay, the next one, I'm looking for at least 10 successes and 10 failures. I do need to check this for both groups. So first group had 49. It tells me that it's going to be 35 successes. I'm going to change that to a proportion by just doing 35 divided by 49. So that gives me roughly 71. So if I'm checking for the quote failures, 1 minus 0.71 gives me 29 times the 49 gives me about 14. Those are definitely greater than 10. Check the next group. So 44 people. I already know the number of successes is 32. Again, doing 32 out of 44 gives me 73. So about 12. Definitely greater than 10 again. Okay, the last condition that I want to check here is to make sure that my samples are independent. These ones definitely should be independent. My guess is that we do not have women that are in both groups receiving both the drug and the placebo. Okay, N is naming the test. These are two proportions. I'm using z-scores for proportions, and I'm running a hypothesis test. For T, what I'm going to do here is find the difference between my two proportions. So I'm going to find p hat 1 minus p hat 2. P hat 1 was the percent of healthy women who took Prozac, so I found that to be 71. Minus the percent of women with the placebo, so that was 73. So this should give me negative 0.02. Let me check though. Yep, we are good. Okay, from here I can start to solve for O, where I am obtaining my p-value and building that model. Now, because I have these two proportions, and my assumption from the beginning was that the proportions are the same, I am going to need to find p hat pooled. You will always need to pool your data if you are given two proportions and you're running a hypothesis test. So I'm going to take the number of successes from my first group, it was 35, plus the number of successes from my second group, which was 32. And I'm going to divide by the totals of each group, so 49 and 44. Okay, we're going to change this into a proportion. So about 72%. Now that I have this p hat pooled, I can use it to find my standard deviation. So I'm going to open up my big square root. Instead of using the two p hats that I had over here, I'm just working with that 72. So I have 0.72 times 1 minus 0.72 over the first group, which is 49. Plus the 0.72 times 1 minus over the second group, which is 44. Okay, we get 0.933. Once I have that mean and standard deviation, I can draw in my model. Mean is at 0.72, standard deviation we just found. Oh, I'm sorry, my mean is not at 72, that was just my p-hat pooled. My mean, which I didn't really even write on here, but my expected value of p-hat 1 minus p-hat 2 should always match my null hypothesis. So I'm expecting those differences to be 0. I'm going to drop down my test statistic, which was over here, this negative 0.02. I'm shading to the right because it's a greater than sign, which seems, kind of weird. We're shading more than half of our picture. Again, we'll change that proportion into a z-score. So negative 0.02 minus 0 over my standard deviation. I'll then use normal CDF to find this area. My lower bound should be that z-score of negative 0.21. My upper bound is just a very large number on that right-hand side. Mean and standard deviation stay the same. So we get 0.5832 for our p-value. Okay, once I have that p-value, I can make a conclusion. So I'm going to say that since 0.5832 is greater than 0.05, we fail to reject H naught. Okay, if I'm failing to reject H naught, that means that I do not have evidence. So I'm going to say we do not have evidence to suggest that this right here, so I'm going to say the proportion of healthy women with Prozac is greater than the placebo. So we do not have evidence to suggest that the percent of healthy women taking Prozac is greater than percent taking placebo. So essentially what we're saying here is that we do not have evidence to suggest that Prozac is working any better than a placebo. And again, we can check our work here by using our calculator. When I go to stat test, I should be looking for a 2-prop z-test, so that's number 6. It's asking me for the number of successes for each group. So looking here, I should have 35 out of the 49. Second group was 32 out of 44. Again, make sure both of those x values are whole numbers. I was looking for greater than in my alternative hypothesis. When I go to calculate, it should give you your z-score here, which mine is off slightly, and our p-value too, but they should be pretty dang close.